Welcome to the third video on integers. In this video, we are going to talk about exponents and order of operations. So we'll start with exponents. If we multiply a number times itself, we can write it in what's called exponential form. The number that is getting repeated is written normal size. It is called the base, so here 2 is the base. And however many times it has been written out, that number is your exponent. So here we have 5 2's, then our exponent, or power, sometimes it's called power, is 5. And we would read this 2 to the 5th power. The exponent or power is written a little smaller and it's superscript. So it's written a little bit higher than your normal base. Notice the operation is multiplication. So when you see a base with a power, then you're going to write that base out however many times your power tells you, and it's multiplication between the numbers. When it's written out with the multiplication, it's called expanded form, and when it's written with the exponent, it's called exponential form. One other thing to keep in mind here is if the base is a negative number or is a fraction, the exponential form must have parentheses around the base. And we will see that in our next slide. So here our base is -8, and so when we write it in exponential form, we must put parentheses around that -8. And then our exponent goes on the outside of the parentheses. And here's an example with fractions. So 2/3 is our base. It would have to have parentheses around the fraction and then the exponent on the outside. Notice if you just wrote 2/3 and then your power, it would look like the power is only on the 2. And you would get a different answer if you did 2 to the 4th divided by 3. So that would not be correct. This way we know that it's the 2/3, the whole fraction, that needs to repeat 4 times. So let's practice evaluating with exponents. I'm going to go ahead and write out the expanded form. After you get used to these problems, and if the numbers are relatively small, you may not need to write out that step. But let's go ahead and do that for now. So 5 to the 3rd power, which can also be stated 5 cubed. Whenever your exponent is a 3, you can say cubed. So 5 to the 3rd power, or 5 cubed, could be written as 5 times 5 times 5. And now we're going to evaluate, which means go ahead and find the final answer. So we'll start with 5 times 5, which is 25. And then 25 times 5 is 125. So that would be our final. Look at number 2. This time our base is a fraction. So we're going to write out the fraction 3/4 4 times with multiplication between. And you can use the dot for multiplication, or you can use parentheses if you prefer. And now we're going to multiply these fractions. We haven't talked about that yet, but multiplying fractions is just multiplying across the top and then multiplying across the bottom. If it's easier for you, you can do 2 at a time. So if I did these first 2, I would do 3 times 3 is 9, and 4 times 4 is 16. And then I'm going to do the second 2, 3 times 3, 9, 4 times 4 is 16. And now multiply across the top is 81. And across the bottom, 16 times 16. If you don't know that, go ahead and just work that out to the side. You should get 256, and this fraction cannot simplify, so that would be our final answer. One thing to think about to make sure you don't make this mistake, and I see this done a lot, is sometimes when students are working a problem and they see something like 5 cubed in the problem that they need to do, they just automatically want to do 5 times 3 and call it 15. So be careful that you don't do that. 4 squared is another one. I always see students want to say, well, 4 squared is 8, but 4 squared is not 8. It means 4 times 4, so it would be 16. So just be careful that you do not multiply the base times the exponent. Okay, number 3. Our base here is -2. It's inside the parentheses. So when we expand it, it's the -2, that whole thing that gets repeated 5 times. And now we can multiply it all in one step, or we could go ahead and just start pairing up here. So if I do these two, that's going to equal a +4. And if I do these two, that's going to be 4. I'm going to drop down that last -2 there. And now I'll do 4 times 4. And then 16 times -2 would be -32. So let's think about the sign. We kind of discussed this when we were doing multiplication in the second video. I have an odd number of negatives once I expand this out. And so that tells me I will have to get a negative answer, because when I start pairing up, there will always be a negative left over whenever my exponent is odd. So you can keep that in mind as you're working these problems, that when you have an odd number of negatives, which comes from the odd exponent, you should get a negative answer. Now, number 4 is different. It does not have parentheses in it. So, and this is something you have to be really careful about and try hard to understand. And even if you work on it and you're like, I still don't get it, then you may just want to memorize that in this type of problem, the negative does not get repeated. That exponent only belongs to the 2, not to the negative, because there are no parentheses. So what I like to do is just drop that negative sign down. And then I'm going to hold it out, okay? It stays out front. And then I just ignore the negative and say, okay, well, 2 to the 5th would be 2 times 2 times 2 times 2 times 2. And then on the next step, that negative still comes down. When it's out in front with no parentheses, it will stay all the way through the problem. And then I'm going to do 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I actually get the same answer, but my work is different. It's important that your work is correct. To get credit for a problem on a lab or a test, your work must be correct. Now, another way, if you prefer this, to think about this is think of that negative as a -1, and it's multiplying by 2 to the 5th. So it's a -1, and we know that 2 to the 5th is 32, ends up as a -32. So if you like that way better, either of these is fine with me. So number 5 and 6 are going to give us a little more practice with that. Now this time the exponent is even. And when that happens, you actually do get a different answer depending on whether you have parentheses or not. So on number 5, we do have parentheses. Then the whole negative gets repeated. -3 times -3. And that, of course, multiplies to be +9. But on number 6, when there's no parentheses, I just keep the negative out front. I'm going to put the parentheses here just to separate that negative. It's on its own. And then I do the 3 squared. And I'm going to keep that negative out in the front. and I do 3 times 3 is 9. So my answer is -9. With the parentheses, I get +9. Without, I get negative. And anytime you've got a negative out front, a base and an exponent, no parentheses will always give a negative answer. So again, really study that. Try to understand it the best you can and just make sure you practice it enough where you're getting those right every time. Number 7, 0 to the 7th power. We do not have to expand this one. We know that if we multiply zeros together, no matter how many zeros there are, we'll still get 0 as our answer. Similarly, on number 8, there's no need to expand that. I don't expect you to write 95 ones. Just think about it. If I start multiplying ones together, 1 times 1 is 1, times 1 is still 1, and so forth, we would get 1, no matter how many ones we multiply together. Now we're back to a negative base inside the parentheses. Here again, I don't expect you to write out 50 negative ones, but let's write out a couple here. Since there are 50 negative ones, there's an even number of negatives. And remember that when you have an even number of negatives, they all pair up, so same signs makes a positive answer. Let's write that here. A negative number with an even exponent, as long as there's parentheses, is going to give a positive answer. Now we multiply all those ones together, just like on number 8. 1 times 1 times 1 is still 1. Positive 1 because of the even exponent. Now number 10, we do have the parentheses, but we have an odd exponent. So if we were to write out the negative ones, and we start pairing them up, since there's an odd number, there will be a negative left, causing our answer to be negative. So that goes here. Let's put a different symbol on that one. When our base is negative and an odd exponent, we will get a negative answer. And so, again, you multiply all the ones together, you get 1, and the odd exponent makes it -1. So number 9, we'll put that same symbol. It goes along with getting a positive answer. And number 10 is going along with this second statement that when my exponent's odd with the parentheses, I will get a negative answer. Okay, next topic is order of operations. You've probably studied this in some math class in the past, and maybe you learned it as PEMDAS. Or maybe you learned the saying, "Please excuse my dear Aunt Sally." So certainly you can still use those to help you remember the order of operations. However, rather than the P being only for parentheses, our first step is to do any grouping symbols. Now, a lot of times that is going to be parentheses, but it could also be square brackets or even absolute value bars. And so whatever grouping symbols you have, you start with those and you begin with the innermost. If there's more than one set, begin with the innermost. Also, if you have a division bar, so you have a fraction, you treat the terms above and below as if they were in parentheses. So for example, if I had 4 plus 5 over 3 times 2, then even though I don't see parentheses around that 4 plus 5, because it's in the top of my fraction bar, I would go ahead and add those first. Sorry about that. So it would be 9 divided by 3 times 2. And then I would do 9 divided by 3 and 3 times 2 last. Okay, and that's going to bring up something else that we will talk about as we keep going here. So number 2 is exponents. Anytime you have exponents, that's what you would do second. Third, you multiply and divide. Now this is what I was referring to over here. When you multiply and divide, it's in order left to right. A lot of people, when they learn PEMDAS, they think they should always multiply before they divide, which is not the case. Those are on the same step. You just work them left to right. So here, this is the same thing as 9 divided by 3 times 2. So I've got division and multiplication. I am going to divide first because that's to the left. So I'm working left to right. Then the first thing I come to is the division. So I do that and then I multiply. Very important to know that. And then last, you do the addition and subtraction in the problem. So grouping symbols first, then the exponents. Third, multiply and divide left to right, and last, add and subtract. Left to right, usually, sometimes there's some room to work that, not necessarily left to right, but that will always work if you choose to do it in that order. But make sure you do all your multiplication and division before you do any addition and subtraction. Let's practice. Number 1. We don't have any parentheses, no grouping symbols. We don't have any exponents. So we do have some multiplication and division. So those will come before the addition. So I'm going to just bring down my 2 to the next step, and I want you to show each step. Anything you're not doing, bring down, make it nice and neat. And here is like what we just talked about. We work left to right for these two operations. And so since the division is on the left of the multiplication, we would do it first. So I'm going to bring down my plus, and I'm going to do 15 divided by 5 and drop down the times 4. So I want you to write it out like that. And then I've got addition and multiplication. So I'm going to do the multiplication next. So I'm still going to drop down the 2 and the plus, and I'm going to do 3 times 4 is 12. And then the addition last. So I want you to go down your page. Don't try to write up above your problem. Down your page and bring down each part of the problem and box in your answer at the end. Look at number 2. So we have some square brackets, and then we do have parentheses, but those parentheses are just there as a symbol for multiplication. It is not telling you to do something inside since there's only one number inside. So we're working inside the brackets. Let's go ahead and keep those brackets on there. Inside the brackets, I've got addition and I've got multiplication. So I need to do the multiplication first. So I'm going to bring down the 7 plus, and I'm going to do negative 6 times 3, and that's going to be a negative 18. Different signs, negative answer. So I'm still working inside the brackets. Bring down the 12, bring down the minus, and now we're going to do this operation. We're adding and we have different signs. So the rule is subtract, so 18 minus 7, and take the sign of the larger, which is negative. So we get a negative 11 when we do this 7 plus negative 18. And I'm going to go ahead and put parentheses there just to separate these negative symbols. Now, so we're subtracting. Leave, change, change. Add the opposite. So subtraction becomes addition. Opposite of negative 11 is 11. And then we add those. 23 is our final answer. Okay, here's a couple of more. This one, number 3, does have parentheses, and inside the parentheses we have an exponent. So let's do that first. Bring everything else down, and we're going to do 3 squared. Remember, 3 squared means 3 times 3, which is 9. It does not mean 3 times 2. Bring everything else down. If you want to, you can go ahead and do this other exponent in the same step. So this would mean 2 times 2 times 2, which is 8. Okay, now we still have an operation inside the parentheses to do. So we're going to do 9 minus 15. Now if you still need to do leave, change, go ahead. Or maybe you're to the point where you know that is a negative 6. All right, so now I have an addition here, and a multiplication in the middle. So that multiplication is my next operation. So I'm going to bring down the 12. And right here you have a choice of putting your plus sign. Let's just say you did that. And then you said, okay, a positive times a negative is going to be a negative. So plus negative 24. You can write it that way. In fact, I think I did that on number 2. Or you can go ahead and think of these signs as being on the numbers and saying, okay, this positive 4 times this negative 6 is a negative 24, and just write minus 24, which is the same thing as plus negative 24. Remember, add the opposite, it becomes the same thing. So either way is acceptable. I usually would just go ahead and write the minus sign. So now here we are down to just addition and subtraction. So you could do the 12 minus 24 first and work left to right. Usually students are more successful when they go ahead and do it that way. So let's do that. 12 minus 24 is negative 12. And then drop down the plus 8. And then we're going to do negative 12 plus 8. Signs are different, so we subtract and take the sign of the larger. So negative 4 is our final answer there. Okay, we're going to keep practicing. Here we have some absolute value bars in our problem. And remember, those are treated like grouping symbols. Those are innermost, so we're going to work inside. We've got multiplication and we've got an exponent. So let's just start bringing everything else down. We still need the bars on there. Now I could actually go ahead and do the 2 times 3, bring the minus, and go ahead and do the 4 squared at the same time, which means 4 times 4. Now the minus is out front without parentheses. It is not being squared, so it stays out front, right? If I wrote it like this, that would be negative, and then I do the 4 times 4. The negative stays out front. As opposed to if it had parentheses around the negative 4, then you would end up with positive 16. Okay, back to our problem here. So we're keeping that negative, we keep that bar, and then parenthesis. So we still have an operation to do inside the bars. So let's see what we can do there. And so I'm going to write the bar down, and I'm going to do 6 minus 16 is a negative 10, and I still keep the bars on. The only way the bars can come off is to actually take the absolute value. So that's what we'll do next. Bring down the 2, bring down the plus. The absolute value of negative 10 is positive 10, and then the bars come off. Now we work inside the parentheses, and we do 2 plus 10 is 12. And last, we multiply the negative 6 times the 12 is a negative 72. Learn those 12s if you haven't learned them yet. Okay, we've got one more example of order of operations. This one has a fraction bar in it. So we are going to do order of operations on top and on bottom, and then we'll divide last. After we do that division, then the exponent, which is on the outside of the parentheses, will be done. So bring down everything as you go. On the top, the first thing I'm going to do is the exponent, and then the multiplication. And really, those could be done in the same step. So I'm going to do 9 times 2 is 18, minus, and then I'm going to come out to the side here, negative 2 cubed. Remember, that's negative 2 times negative 2 times negative 2. That's going to end up being a negative 8. So I've got 18, I've got a minus, and now I've got a negative 8 on the top. Let's move to the bottom. 4 squared, 4 times 4 would be 16, plus 3, and here's an exponent. Do not multiply that 3 to the negative 1 because you have an exponent on the negative 1. So you're going to do that negative 1 to the 5th power. So you're going to have an odd number of negatives, which is going to make it negative, and 1 times 1 times 1 times 1 times 1 is still 1. So negative 1 to the 5th is negative 1. Then go ahead and put big parentheses and the square. Back to the top. 18 minus negative. Remember, if you need to, leave, change, turns that into 18 plus 8. On bottom, 16, I'm going to multiply on the bottom, the 3 times the negative 1. So it's positive 3 times negative 1 makes a negative 3. Keep the parentheses on the very outside with the exponent. Back to the top, 18 plus 8 is 26. On the bottom, 16 minus 3, parentheses, squared. So if you can divide, if this numerator is divisible by the denominator, go ahead and divide them. Now, if it were a fraction where the top was not divisible by the bottom, then you would just simplify your fraction and do your exponent. But here, we get a nice whole number. 26 divided by 13 is 2. And finally, I apply that outside exponent. 2 squared is 4. So if you have any questions on any of these examples, be sure to let me know, and we can go over some more in class if we need to. Practice the homework problems, and if you need more practice than that, you can certainly go online and find lots of order of operation problems that you can do. I hope that this was helpful, and again, let me know if you have any questions.